In this video, we're continuing section 5.2 on y equals e to the x, and we're going to focus on the graph of that function and transformation, so when it gets shifted, when it gets reflected. Okay, so let's sketch the graph of this function, and then we'll state the domain, the range, intercepts, and asymptote equation. So all the types of normal things. Okay, so when we talk about the graph of y equals e to the x, well, it's got the same shape, same general shape as what we've seen for like 2 to the x or 3 to the x. But just keeping in mind that e roughly as a decimal is about 2.7. It's about 2.7. So if I plug in a couple of numbers into this function, like if I plug in x equals 0, my y value is e to the 0, but something to the 0 power is 1. So I know if I plug in x equals 0, my y value is 1. Okay, and then if I plug in another x value like 1 into this, my y value is e to the 1, which is e, and that is about 2.7. Okay, so when x is 1, my y value is about 2.7. Okay, and then it's going to have the same general shape as what I saw with these exponential graphs, which is, going this way, it gets higher and higher and higher, more and more quickly. Going the other direction, it kind of snuggles up next to that x-axis. Okay, and recall that when we have an exponential graph like this that hasn't been shifted, it hasn't been reflected, this initial point on the y-axis, we call that the balance point. Okay, so later in this section, in this video, we'll see examples where, this graph might get shifted to the right or shifted down or left or up, and then the balance point may move around. Okay, but so far this hasn't been shifted, so the balance point is just here on this y-axis. Okay, so my domain, my x values, well, looking at the graph, the x values can be anything. It's just negative infinity to positive infinity. For my range, for my y values, well, the y values seem to get smaller and smaller and smaller, but they get really, 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 really close to 0, but they never reach 0. So I put a parentheses at 0, and then they get bigger and bigger and bigger and bigger, going to infinity. Okay, my y-intercept is this point. It is 0, 1. There's no x-intercept. It never crosses the x-axis, so none. And this graph has a horizontal asymptote, and that is just here on the x-axis. So the equation of that line is, so for every single point on that line, notice that they all have the same y coordinate and y equals 0 for every single point on that line. Okay, so my horizontal asymptote, its equation is y equals 0. Okay, so there's my info about my e to the x graph. All right, let's flip the page. Let's do another example. So now let's graph 2 to the x and 3 to the x and e to the x on the same set of axes to see how they compare. Okay, so with all of these graphs, if I plug in x equals 0, well, something to the 0 power, that's just going to be 1. So they are all, when I plug in 0 for x, the y value is going to be 1 for all of them. So they're literally all going to go through that point. Okay, so let's start with a graph of y equals 2 to the x. We graphed this in the last section. So if I plug in 1 for x, 2 to the 1 is 2. So if I plug in 1, my y value is 2. And then it's going to have my exponential growth shape going up quicker and quicker and quicker, and this way snuggling up next to the x-axis. So that's y equals 2 to the x. And now in a different color, what about y equals 3 to the x? Well, if I plug in 1 for the x, 3 to the 1 is 3. So now my y value there is 3. I know it also goes through this point. So now it's just growing quicker and much more quickly. And then going this other direction, it still snuggles up next to the asymptote, but just more quickly than the first graph did. So that's y equals 3 to the x. Okay. And then finally, I need the graph of y equals e to the x. Well, the key thing to know is that, well, e is something that's between 2 and 3, right? Because e is about 2.7. So when I plug in 1 for this x, the y value is about 2.7. So it's about 2.7, which is somewhere here-ish. I'm going to label that as E. Okay, so when x is 1, the y value now is here, about 2.7. So if I connect that, I am starting to get this shape. And going the other direction, it still snuggles up next to that horizontal asymptote, but it's between the other two. So that's my graph of y equals e to the x. Okay, so what changes in these exponential function graphs is how quickly they are growing. Okay. All right, let's take a look at one more example in this video where now we have something a bit more complicated. So I have f of x equals e to the x minus 4 plus e to the third. Okay, and I want to do the usual stuff like getting the domain, range, intercepts, and asymptote equation. Okay, and I'm going to include balance point in that list. Okay, so I'm going to do this by shifting and reflecting. So what's our parent function? Recall the parent function is kind of the simple function that we know whose formula looks most like this. Well, now I have y equals e to the x at my disposal that I can use. So let me draw some axes. And just getting ready for the next couple of steps, let me draw a few more axes for when I'll have to shift it and reflect it. Just getting ready for those. Okay, so I'll start with the graph of y equals e to the x. I'll label this more generally. My initial function is f of x. But we just saw the graph of y equals e to the x. It's got the same exponential growth type shape. Snuggles up next to this x-axis over here, asymptoting there. Okay, and then this initial balance point is at 0, 1. Okay, so what do I deal with next? Like, do I deal with the fact that I got this x minus 4, or do I deal with the fact that we got this e to the 3 out here? Remember, we work inside out generally when we deal with these transformations. So the next most inside thing, I think, is this x minus 4. So what we're going to be doing is taking our previous function, and we're going to replace the x in this exponent. We're going to replace that with an x minus 4. So in terms of my general formula, f of x, we have f, but now I'm replacing the x inside with an x minus 4. So when I do that, when I replace the x inside the function with x minus something, well, that's a shift to the right. It shifts it right by 4. Okay, so I'm going to start with the balance point because I know that concretely. If I shift that 4 units to the right, well, now it's at 4, 1. Then I get the same general shape, so increasing that way. This way it's decreasing, and it snuggles up next to that x-axis for my asymptote. Okay. All right, one more step to go. I got to add this e to the 3 at the end of my formula. So I get y equals e to the x minus 4. And at the end, I'm adding e to the 3. Okay, so in terms of my general formula, previously I had f of x minus 4, and now I'm adding e to the 3 at the end. So adding a number like that at the end of a function, that shifts the whole thing up. So that shifts the whole thing up. Up by e to the 3. Shifts the whole thing up by e to the 3. Okay, so when we do that, so let me shift up this balance point. So when I shift up that balance point, now it's higher. So that balance point is at, it's at 4. X coordinate doesn't change, but the y coordinate becomes 1 plus e to the 3. And that can't really be simplified. And before I draw the shape of the graph, when I shift the whole thing up, that is also going to shift this horizontal asymptote. So let's draw the horizontal asymptote shifted up. That horizontal asymptote gets shifted up, and that is going through, it used to go through 0, but now it's going through e to the 3 because the whole thing got shifted up by e to the 3. Okay. And now let me go ahead and draw the shape of the graph. So this way it increases really, really quickly. The other way it snuggles up next to my horizontal asymptote. Okay, so I'm just labeling this point right here as my balance point. So when I have a problem like this where my exponential graph gets shifted or reflected, well, that balance point that initially starts off on the y-axis, it can move around. Like it moved to the right 4, then it moved up. So it's very important when you draw your balance point, draw it in the very first graph, because then you can track what happens to it step by step. If you don't do that, it's actually quite hard to recognize. It's much harder to recognize where it's going to be at the end. Okay, so I got the shape of my final graph. I need intercepts. So let's get those. So y-intercept. For my y-intercept, I plug in 0 for the x. So I'll plug in 0 for the x in my formula. So that'll give me y equals e to the -4 plus e to the 3. And there's no exponent rule that I can use to simplify this. So if I write this as a point, this is 0 comma e to the -4 plus e to the 3. Okay, so if I go to my graph and I label that, and I label this, I'll need a different color, my y-intercept, it's at 0 comma e to the -4 plus e to the 3. That is my y-intercept. Okay, awesome. So let's box that. We got y-intercept. Let's get the x-intercept now. So x-intercept. For my x-intercept, I plug in 0 for the y. So I would get, here's where y is, so I will get 0 equals e to the x minus 4 plus e to the 3. If I rearrange this, I'll move e to the 3 to the other side. So that gives me negative e to the 3 equals e to the x minus 4. Okay, so e to the 3, if I stick a negative in front of the whole thing, well, that ends up being a negative number. This is some negative number. But on the other side, well, e is a positive value. It's about 2.7. And if I raise, about 2.7 to any power, that whole thing is going to be positive. This whole side is going to be positive. So because of that, this equation has no solution. No solution since e to the x minus 4 has to be positive. It's got to be greater than 0. So I tried to find x-intercepts. I got no solution. That means there are no x-intercepts. And of course, that makes sense based on my graph, because I can see that on the graph. There are no x-intercepts. Okay, but this is helpful to be able to recognize, because sometimes a problem will ask me to get the x-intercepts by solving for them. Or maybe I don't have the luxury of the graph to help me with it. Okay, so I got my x-intercept. There is none. Now let's do our domain and range and asymptote equation. So my domain, my x values, well, looking at the graph, x can be anything. So my domain is -infinity to +infinity. My range, my y values, well, the y values get really, really close to e to the 3, but they never reach e to the 3. I never touch that asymptote, so I'll put a parentheses there. But then they get bigger and bigger and bigger, so onwards to infinity. And there is a horizontal asymptote. So a horizontal line always has the equation like y equals something. In this case, my line is going through the y value e to the 3. So it's y equals e to the 3. All right, and we got it. Got our domain range asymptote. And we got this final graph. And there we have it.